We are on lesson 20. We are on question number 5. This question is a little bit more of a challenging question. It can take a little bit of paper to solve. What it's trying to do is get us to come up with an equation. What we've been doing is we've been given the equation and we've been trying to find all the zeros, whether it was to the second power, third power, fourth power, whatever. What we're going to do is we're going to be given some information and we want to come up with the equation that is a part of the information. If you remember in Algebra 1, we did all those regressions. We went from a table and turned it into a linear equation. Then we went from a table into a quadratic equation. So making equations has always been a challenging part of mathematics. So this is maybe a little challenging, but it's not something that we can't do. Now, here's what it's telling us. It's telling us that n is 3. Now, what that means is it's an nth degree polynomial. That means we're going to have y equals something x to the third. Okay? It's a third degree polynomial. So we're going to have something x to the third plus something x squared plus something x plus something. And guess what we're trying to find? All of those somethings. Okay? So it tells us that it's a third degree polynomial. But then it tells us 2 roots. It gives us 2 roots. It says that there is a root, a 0 of -5. Now, if there's a 0 of -5, then there must be a factor of what? If the root is -5, what's the factor? X plus 5. Because if you set that factor equal to 0, you would get the root. So if the root is -5, the factor must have been x plus 5. Okay? You understand that? So, again, how do you get a root then? You get a root by taking x minus, you get a factor, you get a factor by taking x minus a root. If the root is -5, then you would have minus a -5, which turns into a plus 5. But everybody understands that, okay? So we have one of the factors. Now, the next factor is an imaginary factor. And remember when you do the quadratic formula, x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. When we got an imaginary factor, there's a plus or minus, and they always came in pairs. Remember that? And if we had a radical factor, they always came in pairs, the plus that and the minus that. That means if we have a root that's an imaginary root, like 4 plus 3i, then the negative of that would also be a root. The 4 minus 3i would be a root, okay? The plus or minus the square root of, okay? So, that means that we get what 2 roots out of that? How would we get the roots out of that? Well, to get the roots out of that, you would do x minus that, right? And then x minus the other one of that. So if we had x minus that 0, it would give us a factor. If there's a 4 plus 3i factor, then there must be a 4 minus 3i factor, right? Because there was a plus or minus here. That 3i came from a plus or minus situation, so you're going to have a plus that and a minus that. Okay? If we clean those up, then our first factor is the x plus 5. Our second factor, if we distribute, is x minus 4 minus 3i. And our next factor is x minus 4 plus 3i. And so those are the three zeros, the three factors of our polynomial function. Okay? So they gave us the zeros. We put them in the form of x minus that and got the factors. Now, with the factors, we can multiply those things out. Okay? It's going to be a lot of stuff. I'll let you catch up. Does anybody have any questions so far? So we're going to try to begin to put it in this form. And the way we're going to do that is to start multiplying. And when we do, we're going to multiply the imaginary ones first. We can multiply in any order that we want. We'll do that first. Now, remember when we do that, we're going to send the x through. And so we're going to have x times x is x squared. X times negative 4 is negative 4x. X times 3i is 3xi. They see that when we sent the x through. Then we're going to send the negative 4 through. I'm going to go ahead and put my like terms together when I do this. Negative 4 times x is negative 4x. Negative 4 times 4 is a negative 16. I'm going to put it out here. Negative 4 times 3i is negative 12i. I don't have any of those either. So negative 12i. I guess I can put it here. I'll just drop it down. And now we need to send the negative 3i through. Negative 3i times x is negative 3xi. That was negative 3i times x. Negative 3i times 4 is positive 12i. Positive 16, yes. Thank you, ma'am. Negative times a negative is a positive. Now we're on negative 3i times negative 3i. Negative 3i times negative 3i is negative 9i squared, correct? But what's I squared? Negative 1. So that's negative 9 times negative 1, which is positive 9. If I see how we got that? That was the negative 3i times the 3i is negative 9i squared, which turns into a 9, and it's positive, and so we're going to have a plus 9 with that. Okay, so I multiplied my two imaginary factors together first, and we're going to have some 3xi's that cancel, and we're going to have some 12i's that cancel, and then we're going to have x squared minus 8x plus 25 when all the imaginary stuff canceled out of it there. Now, I put equals 0, but I could just put equal y. If we wanted it in y equal form, I should probably just be putting y equal. Because we're not trying to find the zeros, we already know the zeros. We're trying to find the equation. Now what we're going to do is multiply again. So we're going to send the x through. X times x squared is x cubed. X times negative 8x is negative 8x squared. X times 25 is 25x. And then we'll send the 5 through. 5 times x squared is 5x squared. 5 times negative 8x is negative 40x. 5 times 25 is 125. And then we'll combine like terms. We're going to have x cubed minus 3x squared minus 15x plus 125. And we can put y equal. Any questions on how we got to that point? So the question is that the answer, which was fixing to be my question. Now, let me just do something small for you. Let's say that we had 2x plus 1 equals 0. Okay? What if we multiplied both sides by 2? What would we get? 4x plus 2 equals 0. What if we multiplied by 3? 6x plus 3 equals 0. So the idea is because the zeros, because those factors came from zeros, that means that the equation that we found could be a simplified version of the real one. So how do we figure that out? How do we figure out what the real one was if it may have been simplified? And this last piece of the puzzle they gave us for that purpose. The other thing they said is if F2 is equal to 91. If F2 is equal to 91. So what would we do there? What would we do on that? Now, look at this situation here. If I've got this equation multiplied by 3, then it would have looked like this. 3 times 2x plus 1, right? So what I'm looking for then is the factor that I've enlarged or reduced by. Okay? So how could I write that? Well, I could write it like this. Let me get rid of some stuff up here. I could take this equation and I could say, well, I could think of it in this form. A times x cubed minus 3x squared minus 15x plus 125. My real equation is something multiplied to that base, right? My real equation is some a times each of those that got factored out. And so if I could just find that a, I could multiply them all by that and get the real equation, right? And it says f of 2 is equal to 91. So what could we do with that? The function value at 2 in the real equation comes out to be 91. That means in the real equation, there's going to be a 91 there when there's a 2 in every x position. Now, if I were to plug in that 91 and that 2, the only thing left would be a. And I could find the a that got factored out, you see. And so I'm going to have 91 is equal to whatever that factor was times my x of 2 cubed minus 3 times my x of 2 squared minus 15 times my x of 2 plus 125. And I have an equation with only one variable a that I can solve for. Okay? And so I'm going to have 91 is equal to a times, what do you get when you do 2 cubed minus 3 times 2 squared minus 15 times 2 plus 125? Y'all throw that in the calculator and see what it kicks out. So we get 91. So we would then undo multiplication by division, and we get A is equal to 91. A is equal to 1. Well, what that tells me then I'm going to do is I'm going to have then y is equal to my A of 1 times x cubed minus 3x squared minus 15x plus 125. And I'm going to distribute that 1 to get the real equation, which is the same. So we really got the real one to start with. But if that had been a 2 or a 3 or anything else, it would have changed the coefficient of every single number when you multiplied it by that. In this particular case, when you multiply by 1, it stays the same. And that's the equation of the cubic that has those particular characteristics. Any questions on that one? It wouldn't hurt to just stop and record that whole thing again. I think we'll just do it again. Probably wouldn't hurt. I know those watching could fast forward, but y'all need to see it again. I would assume I would have. All right, let me let you catch up, and then we'll go through it again. You'll have all the notes taken, and then we can just run through it again. We could come up with one out of the textbook and do one out of it. All right, y'all ready? We'll just do this one again. This is good on our mind. All right, don't go to sleep on me. Too much fun to do that. Okay, we're wanting to find a polynomial of the third degree. That means we're looking for a y equals something x to the third plus something x squared plus something x plus something equation, where the zeros of the equation are this and the conjugate of that, because if you have an imaginary or radical root, it automatically comes with its conjugate. And remember, the conjugate, you just place a plus to a minus there, okay? So what did the n equal 3 give us? It gave us the degree of the polynomial we're trying to find. If we're trying to find roots, if we're given roots and we want to find factors, we find factors by going x minus a 0. So x minus the 0 of negative 5 would look like that. X minus that. Now, we have to put that in parentheses, we know, and distribute. And then we know if we have this as a 0, then we're going to have its conjugate as another 0. And on the conjugate, you simply change the plus to a minus. And we're going to say that y is equal to that. Understand how we got that? Now, let's change those to the real factors. Yes. When we solved a quadratic like x squared plus 5x plus 6 equals 0, we would say, what do you multiply to get 6 and to add to get 5. And we said, well, that's a 2 and a 3. And so that factors into x plus 2 and x plus 3. So these are factors. If we had x plus 2 is equal to 0, then we would solve and we get x equal negative 2. So when the factor is an x plus 2, then the actual 0 is a minus 2. Because of that, we have to put a minus because there's a sign change going on. So when you put a minus in the formula right here, it gives you the desired sign change, going from a 0 to a factor. Okay? All right. So when we clean this up a little bit, we're going to have minus a negative 5 is a plus 5. We're going to distribute that negative, and we're going to get x minus 4 minus 3i. And we're going to distribute that minus and get x minus 4 plus 3i. And so we've got our 3 factors of our cubic. And to get the cubic, we're going to multiply those 3 factors together. But what we get may be a reduced version of the original one. Okay? To do that, we're always going to multiply the imaginaries, if there are imaginaries, or the radicals, if there are radicals, in hopes that there's some canceling that's going to go on. And there's going to be canceling go on. How come? Because they're conjugates, and the result is the difference between the squares. And when we do conjugates, stuff always cancels, you see. So that's why we're going to do it first. Yes. Yes. So we're going to send that x through. It's going to hit every one of those, right? Boom, boom, boom. So we're going to have x times the first one, x squared. X times the second one, negative 4x. X times the third one, 3xi. And then we're going to send the negative 4 through. It's going to hit this, this, this. Negative 4 times x is negative 4x. I'm just going to line up my like terms. Negative 4 times negative 4 is positive 16 this time. Negative 4 times 3i is negative 12i. There wasn't another one of those, so I'm just going to throw it over there. Okay? And then we're going to send the negative 3i through. And it's going to hit all 3 pieces. Bing, bing, bing. Negative 3i times x is negative 3xi. Negative 3i times 4 is positive 12i. Negative 3i times 3i is negative 9i squared. I squared is the same as negative 1. So we have negative 9 times negative 1, which is positive 9. So I have a plus 9. And notice I just kind of put all my like terms together as I went. You could have stretched them out sideways. I just kind of like to do that. That makes all the i's cancel out. The i's don't have it this time. Anyway, so we're going to get x squared minus 8x when we combine our x's plus 25 is the product of those 2 complex root factors, complex factors, okay? Now we're going to multiply the first binomial through, and to do that, we'll just send the x through. It's going to hit bing, bing, bing. X times x squared is x cubed. X times negative 8x is negative 8x squared. X times 25 is 25x. And then we'll send the 5 through. 5 times x squared is 5x squared. 5 times negative 8x is negative 40x. 5 times 25 is 125. And nothing canceled that time. So we're going to have y is equal to x cubed minus 3x squared minus 15x plus 125. Now that's what could be a simplified version of the real cubic. That means that we could have reduced it by some factor a or enlarged it by some factor a if a had been a fraction. Okay. So we need to find the a by which this thing was enlarged or reduced. And the way that we're going to do that is to take this, what we've got so far equation, along with the idea that the function value of the real thing at x equal 2 is 91. So we're going to say there could have been some a that was factored out of the original to give me this reduced thing that I've come up with. And to find out what that a that it had been reduced by could have been, then we're going to say, well, when the value of x is 2, the function value is supposed to be 91. So for what value of a would that be true? And so in place of each of these x's, we're going to put that 2. So we're going to have 2 cubed minus 3 times 2 squared minus 15 times 2 plus 125. And so we have 91 is equal to a times 91. We undo multiplication by division to solve for the value of a, and we get that 1. So the factor by which it was enlarged or reduced is 1, which means it wasn't enlarged or reduced. But it could have been. Had it been any other number, we would obviously need to do this. We would take 91 is equal to the a value that we found, 1, whoops, I should go a little higher there, times x cubed minus 3x squared minus 15x plus 125. We would distribute that a, and in this scenario, I'm sorry, we're going to go back and plug that a in, but we're going to put our y equal x cubed minus 3x squared minus 15x plus 125. We don't need the 91 there in our final equation. We need the y there. Okay. Any questions on that? Probably good to go through that twice. They always get better the second or third or fourth time. Okay. All right. Well, the next thing is the Descartes' rule of signs, and we're going to save that for another day. Some of these things just take a little time and thinking, so we'll make another video out of that. Appreciate your attention.